rule for independent events, also known as the probability of A and B equals probability A times probability B. Right. In number 7, we know that 1 in 5 people, or 20% of people who are adults, belong to a gym. And we're going to make an area model for selecting 2 adults. So having 2 adults is kind of like having 2 dice. We're going to have adult 1 and we're going to have adult number 2. Now the dice, remember there was different outcomes for the sides. We can also have different outcomes for each adult. One outcome could be they don't go to a gym. Another outcome could be they do go to a gym. What we're going to use is this 1 in 5. That lets us know that there should be, actually let's do our rows first. Sorry about that. Let's stop and get our rows set up. 1 in 5 lets us know we're going to use 5 rows for adult 1. And then we're also, since this person is also an adult, they get their 5, except this time it's just going to be 5 columns. All right. So adult 1, he either joins a gym or he doesn't. And there's only a 1 in 5 chance that he does, so we're going to have 1 yes and then a whole bunch of no's. No, they do not go to the gym. Specifically 4. 4 out of 5 no's, 1 out of 5 yeses. Adult 2, he's also an adult. And what this adult does doesn't affect his probability. It's independent, right? Whether or not I go to a gym has nothing to do with whether or not another random adult goes to the gym. Adult 2 also is 1 yes and 4 no's. So we're going to draw and shade an area model to calculate the probability that both people belong to the gym. Well, look, we're just going to shade squares where they both go to the gym. That's a no-no, that's a no-no, that's a no-no, that's a no-no, that's a no-no. In fact, even these don't count. This is no yes. They both have to go. That's the only square where they're both going to the gym. Now it says calculate the probability, so let's look. We had 25 squares. We had 1 instance of them going to the gym. So the probability is 1 out of 25. Let's go ahead and use our multiplication rule. This is an extra question. It's not in the prompt. But look, you have 1 in 5, 1 in 5. That's 1 over 5 for 1 adult times 1 over 5 for the other adult. Probability A times probability B. Multiply these together. Multiply across. 1 times 1, 5 times 5. And we get the same value. We get that 1 in 25. B says suppose you randomly select 2 adults. So we've got adult 1 and adult 2 again. We're going to draw and shade an area model to calculate the probability that only 1 belongs to a gym. So I'm not going to redo the area model. What we're just going to do is use a different color for this shading. We're going to shade in red all the instances where only 1 of the 2 people go. So we're not going to use this. This is both people. This is yes, yes. However, this is no yes, no yes, no yes, no yes. And this is also no yes, or yes, no, yes, no, yes, no, and yes, no. So these specific squares are squares where 1 of the 2 people is going to the gym. There are a total of 8 squares out of the 25. So there we go. Question C, we're not going to do an area model. We're just going to use the multiplication rule. We have 3 adults. Each one of them has a 1 in 5 chance. So the probability of adult A and adult B and adult C, well, it's a 1 in 5 for adult A times a 1 in 5 for adult B times a 1 in 5, times a 1 in 5 for adult C. Multiply those out. 1 times 1 times 1 is 1. 5 times 5 times 5 is 125. So not very good, right? 20%. To get one adult right, it just takes 20%. Doesn't happen most of the time, but you can get lucky. 3 adults in a row, you only have a 1 out of 25%. That's less than 1%. So you have very, very low odds to get something right 3 times in a row. Important thing to remember when you're in Las Vegas gambling, you want to win. Please win money. All right. Be sure to click over for the next video. The next video is on multiplication rule for non-independent events.